start recording now. Guys, tell me any questions you have. We can start answering one by one. And I'm sorry, I was a little bit busy on Thursday, so that is the reason even if Sunday is working for you guys, even we can do this Sunday also every time. So I am all game for that. Okay. Oh, that is good. Then if that works for you, please feel free to tell me, and I'm more than happy to meet you guys. Okay, that is great. Yes, I can do that. Okay, then. So at any point of time, if you have any questions, then I would say Sunday at 3:30. I think depending on the day, we can always change. So we'll meet as well. Other than, again, I can meet on Tuesdays and Thursdays also. I can meet even 3 times a week, whatever works for you. So the first question I got from Melissa is 3.5, problem number 14. Am I correct? Oh, 15. Okay, Melissa is saying 14 and Andrew is saying 15. Okay, let me check. So you want me to tell you how to write the proof? Let us start with 14 then. Okay, 3.5 14. I think I'm pretty sure you're asking about proof thing. Okay, let us start sharing things. And I'm assuming you have no problems in hearing me and all, right? If any time you can't hear me or if you can't see what I'm writing, please tell me, because I'm going to go into the PowerPoint, so I might not be able to see the chart session. So feel free to talk. I'll keep looking at the chart session as well. So let us share application. Man, I couldn't see that. Application window, okay. Share. It is the pens. You all can see the PowerPoint presentation, am I correct? The blank one. Again, as I said, I cannot see the chat session, so you can say yes or no.
Yes.
Okay, that's great. Thanks a lot. Again, this proof is comparatively not very bad. So you need to prove G is a tree. I'm talking about 3.5, problem number 14. So to prove G is a tree, we need to prove two things. Again, I'm going to write down a comparatively a detailed proof for you guys, so it will help you in future. We need to prove G is connected and G has no circuits. Again, if you remember the definition of connectedness, if you take any tree, any two vertices x comma y, that is the definition of the connectedness. I think that is on, if you look in, if you have the textbook, I think that is defined on section 3.1, if I am correct. They will simply say the definition of connectedness is, let me check, because sometimes definitions change from, on page 136, they'll simply tells you connected means if you take any two vertices, there is a chain. So, but according to the hypothesis in problem number 14, if you take any two vertices, they exactly have one simple chain joining them. So G is connected is clearly follows from the hypothesis. So you will simply say G is connected clearly follows from the hypothesis. Hypothesis means the one whatever they have given to you. They simply mentioned in the problem, there are any two vertices if there is a simple chain. So connected is no problem for you. So the only thing you need to prove is, you need to prove G has no circuits. Again, the idea is this. if G has any circuit, something like this, take any two vertices x comma y, then it has two simple chains joining them. One simple chain is like this, and another simple chain is like this. I'll call this is C1 and C2, which is contradiction to the hypothesis, because of hypothesis tells you there's only one simple chain. That's all, you have to write it in words. Simple chain means if you're going from x to y via C1, you can see that you are not going to repeat any vertices, you are not going to repeat any edges. So that is one chain. And if you go on C2, that is another way. There is no intersection. These two are completely different chains. So, but according to the hypothesis, there is only one simple chain. So that is a contradiction. So G should not have any chains. That is what you need to write in your own words, clearly. For example, maybe I will write in my own words, then you can change it or you can write it, it doesn't matter. I will simply say if G has any two circuits, man, I should have get rid of this click to add subtitle thing. Just take any two vertices in the cycle x comma y, take any two vertices x comma y. If G has any circuit, not two circuits, I apologize, G has any circuits, take any two vertices x comma y in that circuit. Then there are two simple chains. There are two simple chains between x and y, or you can say there are two simple chains starting from x and ending at y. And you can draw the picture for a better explanation, and which is a contradiction to the hypothesis. Hopefully you can understand my handwriting there. I'll try to be more legible now, which is a contradiction to the hypothesis. Hence, G has no circuits. So what we proved, G is connected and G has no circuit, so that has to be tree by very definition. So that is problem number 14. Is that clear to you guys?
Yes.
Yes.
Okay, that is great. So now I will go to problem number 15. Okay, if anybody is noting it down, I'll leave it for a minute. Again, I'm going to post this recording also, so you can go back and do that, and you can write it in your own words. How to get rid of this? Let us look at, okay, what is the time? Problem number, oh boy, I'll write it here. Again, the question in 3.515 is this: if you take any tree, that means by definition it has no cycles and connected. If you take any two non-adjacent vertices x comma y, that means there are some things between x and y. So x is here and y is here. They are not nested to each other. If you join them by an edge like this, you are going to get a circuit. So I know a couple of people have any questions. Anybody got this? I want to know what you were thinking before I start writing down the proof. Anybody got it? Again, if you put it on, if you are typing on chat session, I cannot hear you. So can you say yes or no, guys? check in the chat session. Anybody? Again, anybody got it, folks?
I had an idea, but I had
Okay.
I had an idea, but I didn't know if I had it up very well. That seems to always be my problem.
Okay, can you tell me your idea?
Yeah, my idea was that if they were non-adjacent, there was at least one vertex Z on a path between like my other two vertices, which I'll use your words and say X and Y.
Okay.
And then it just if I did draw an edge from X to Y, I think I've created a small circuit, which is, you know, which is what we were trying to prove.
Yeah, you're almost got it, but my thing is you don't need to actually take any middle vertex Z. For example, the way you can do that is this. Maybe share an application, how to make it into full screen. You can say this, guys. So if you take any two non-adjacent vertices X and Y like this. Now, can you see the full screen, guys? I just want to make sure before I write on this. Yeah, it is sharing. Yes, that's good. So all I'm saying is here, take any two non-adjacent, let X and Y be any two non-adjacent vertices. Then I'll call in a tree T. It doesn't matter. You don't need to be specify like this, but I'm trying to give you more elaborate proof. We have one theorem in the textbook. If you look into theorem 3.18, it simply says there is a unique chain joining X and Y. That means between X and Y, I have a unique chain. Maybe I'll call that chain as C. That means I can go from X to Y following this route. There are no edges repeating, no vertices repeating. And now I am joining X comma Y, so I am going to get a circuit like this. That is the idea here. So that's all you need to write it down. So you can say by theorem 3.18, there is a unique chain connecting X comma Y, or between X and Y, or starting at X and ending at Y. It doesn't matter. Now, join X comma Y by an edge. Now we got a circuit. You can draw the picture here. By following the simple chain C. Again, that is exactly the same idea you are mentioning it, but I'm just putting in words. I'm sorry, my handwriting is not great today. But a simple chain C, and then via edge XY. And that is not a bad proof. Again, you can change a little bit here and there, but this is the idea. So the theorem 3.18 is the one which tells me that there is a simple chain X comma Y. You don't need to write down the proof again, because in theorem 3.18 is proved in the textbook, so I can use that statement. Even in the exam, whenever you're writing it, you can simply say by theorem 3.18, because in the exam you can always refer the textbook. You don't need to prove each and everything you write in the exam. If that is proven in the book, feel free to use it. That is 15. Any other questions, guys?
I have a question about section 3.6, question 18A.
Okay, let me look at 18. And before I do it, I just want to make sure you're all comfortable with this, right, guys?
Yes.
Okay. Let us look at 18. So 18A, they were talking about, it seemed they're telling you can get two codes with different heights. You read the algorithm, right? May I know with whom I'm talking?
Yes.
Is it James?
James.
Is that?
Yes.
Okay. James, the idea is this. You need to draw the two trees. I think that is the best way to prove it. That
Okay.
is the only way I think you can, if you can draw the two trees, that is a good proof.
Okay.
I don't think you can write it in any words. You want me to show you how to draw the tree?
Yeah, by going back through the algorithm, I was only getting the one tree, which was
Oh,
like
really?
you take the when you take, so you've got three. Let me go back to
Okay. Okay, I'll go here. 3, 4.
right 3, 4, 7, 14, and 14.
Yes, the algorithm 3.2. Those who have the textbooks, you can look into page number 204. It simply says you are forming trees at each and every step. The way you're forming is take two smallest roots possible. Initial step, I think, James, you can figure it out. These two you will take and you will form this tree. Am I correct?
Yes, 3, 4, and then to 7, and then take
And
7.
the rest of them are going to be there, right?
Right.
Now, what are the two smallest roots are? Can you tell me those numbers?
It'd be 7 and 7 now, right?
7 and 7. So I can do this. This is the next step. Now, what are the two true roots you're going to take?
So now it'd be 14 and 14.
Now here, you'll get two things. Here, if I take this 14 and this 14, I'll get 1.
Okay.
But if I take, maybe I'll change color, this 14 and this 14, I'll get 1 more. For example, I'll take the two blue circle things and try to show you. Okay, let us look into this. For example, this is what I got. Hopefully you can see that. I'm going to go to the next slide, James. Will that be fine?
Yeah. Yeah.
So here, this is what I have so far. 14, 7, 7, 3, 4, and I have two more 14. So I will take one of the 14s and join to this. I'm going to get 28 here. And I had one more 14 left. Am I correct?
Correct.
Now I will take the smallest, means this 28 and this 14.
Yes.
So that is going to give me, what is 28 plus 14?
42.
Okay, thanks a lot. This is 28 and these things will join. 14, 7, 7, 3, and 4. This is one tree.
Yes, that's the tree that I was able to come up with.
Yeah. So the height of this tree is 1, 2, 3, 4, right? This is height is 4.
Yes.
Now go back to the previous slide. Now instead of taking this 14 and this 14, I'll take these two.
Okay.
So I'll go back to this step again. So this is what I have now. I have two more 14s, right?
Correct.
Now I will take this 14 and this 14 and make this one 28.
Right.
So I am not adding this and this, I'm adding these two. Now I will add these two. You can see that these are two different trees.
Okay. I see it now.
Yeah.
That makes sense.
Yes. If they have, it didn't tell you what choice here, so So this height is only 3, 1, 2, and 3.
Okay.
Yeah. So these are the 2 trees you need to draw.
Okay. Thank you.
Oh, anytime. If you show step by step, that is awesome. But they didn't ask that.
Okay.
Yes, sir. I will wait for any others to noting it down. If you want me to go back to any previous slides, if anybody is copying, please tell me. If I'm going too fast, I think it is your job to stop me, because sometimes I tend to go really quick. But it is, make sure. Everybody understood this, guys? Everybody got it?
Yes.
Yep.
Okay, any other questions? Okay, if you don't get it, please tell me.
Could you go over number 15 in that same section?
Okay, number 15. Yes. Okay. Number 15 on section 3.6, 18A and 3.7. So and may I know with whom I am talking?
Chelsea?
Hi, Chelsea. You understood the prefix code? I just want to make sure you understood it before I start explaining this. Prefix.
Yeah, could you go over that too? I mean, I read through it, but I think that's where I'm like stuck.
Okay. Prefix code means all you are trying to do is you are trying to code or decode some bunch of numbers using bit strings. For example, if you go to example 3.33 on page 202, so you have like in that example, I'll go back to that example and then I'll come back to this. You have A, B, C, and D. You have 4 digits. Example 3.33 on page 202. And you are trying to code A, B, C, and D. And there are so many ways you can code it. And most common ways normally people code and decode is using bit strings. For example, if I decided to do a bit strings of length 3, that is something you have to decide. In that example, in that particular problem, they told you what bit string of length want. For example, if I decided, okay, each and every letter I am going to assign with a bit string of length 3. So for example, A, I can read it as 0, 0, 0. That means whenever you see 0, 0, 0, you replace that with A. B, I can say 0, 1, 0 or something like that. And C, you can say 1, 0, 0. And D, I can say 1, 1, 1. So the advantage of doing something like this is, if you see that if I give you a bunch of numbers like 0, 0, 0, 1, 1, say 0, then if you see these bit strings, once you know your each and every bit string of length 3, you will group 3 at a time and you'll decode it. For example, I'll group these 3 and that will become an A, and I will group these 3. Oh, there is no 110 here. Maybe I'll make this as 110 and I'll name that as D. So I decoded this as A comma D. Am I making any sense?
Yes.
Yes. But here I am assuming each and every bit string of length 3. But if you want to save this on the computer, then you are going to have more and more space. That is the reason people use variable lengths. So, but the definition of prefix code is this: you will take each and every letter and assign with a bit of strings. So, and once you have a set of strings given to you like this, you should be able to decode it back. That is the definition of prefix code. This is not very efficient, but this is still a prefix code. We are not worried about what is the best way of doing it or efficient way of doing it. If you look into, for example, on page 203 in the textbook, instead of using bit strings of length 3 each and every time, they used this. A is 0, 1, and B is 1, C is 111, and D is say 10, and if you have another F, for example, that is 010. Here I am not using all bit strings of length 3, so when I'm saving that in the computer, I'm not going to use that much space. But this is not a great prefix code, because if I give you something like this 01011, and if I want to decode it, you don't know, because each and every bit string of different lengths, still it is going to be confusing. So for example, 01, Nisa might be saying this is A, but you might be saying 010 is F, you might be saying it in F. So two people get two different answers, which is going to be confusing. So this is not a great prefix code. So the best way normally people do that is they will take these things and they will draw a tree, that is called, and the tree will help you to figure out. For example, this 100, I'll take this portion, because this is not a great prefix code. This is a wrong prefix code, because though you're assigning digits to things, but decoding is not possible. So a prefix code means this is not a prefix code, because this 01010 have some things in common. That means A is a prefix of F. It shouldn't happen like that. Then that is not a prefix code. So there shouldn't be any confusion when you're decoding it back. For example, take this 0000101001110. Then the way normally I'll write the code tree for that is this. You will always start with a root. 0 means on the left hand side, 1 means the right hand side. It is as simple as that. Since I am assigning in the previous one each and every letter a strings of length 3, your tree should have 3 levels. Left is 0, right is 1. Please remember, this is left 0, right 1, left 0, right 1, left 0, right 1, left 0, right 1, left 0, right 1. I'm sorry, these two are touching. That is just not great. Let me erase that. And again, you will proceed. So then the way you'll do that is, for example, if you look into that A000, so you'll put A here. And B is 010, that means you'll go back into that 0. 0 means you'll coming to the left. And 1 means you'll go to the right. And 0 means you'll come to the left. So this is going to be your B. Oh boy. And C is 100. 1 means you go to the right. 0 means you go to the left, and 0 means you go to the left. Again, I'm not finishing the tree here, but that is the idea of the prefix code and the code tree. Is that making sense?
Yeah.
Okay. So now let us go back into problem number 15. Let us add a slide. Okay, it is not adding that new slide. Okay. Let us look at 15. Where is the pen? Let us look at 15A, for example. You want to write a prefix code. Here D is 4 suits. I think the 4 suits are, I'm not good at, one is, I'll say, clubs. Man, I forgot what are the 4 suits. Anybody remembers what are the 4 suits?
Hearts, diamonds, clubs, spades.
Okay, thanks a lot. I'm too lazy to write clubs, hearts, and all. I'll say C for clubs, H for hearts, D for diamonds, and S for spades. Now in A, they were asking for each and every letter, you want to assign with a bit string maximum of length 2. So for each and everything, you can give a bit string of length 2 or length 1. And that should be a prefix code. So for example, for C, I want to assign, which you have to use only 0, 1. So can you give me a bit string of length 2 or 1 using that? That means 0, 0, 1, 1, something like that. Can anybody tell me?
0.
You can assign 0. You just want to give 0 to this?
Yeah.
Okay. And for H, someone else, can you give me a bit string of length either 1 or 2?
1.
Now you see that you are screwed at this point, because for diamond, which one you want to give? Anyone. Give me either bit string. You cannot give 0 or 1 again, right? So you need to give me something else. Anything. Bit string of length 2 or 1. Which one you want to give? Anybody? Anyone, folks? If it doesn't work, please tell me it doesn't work. If it works, just give me 1. Say, okay, this is a long pause. Let us see. Maybe you guys are figuring out there might be an issue. For example, if I use the 0, 0 here, when I'm decoding it, if you see bunch of zeros, you will wonder, should I use C or D? Somebody give me a chart session. I want to let me see what is going on. Okay, let's go here. You all can see the PowerPoint, right? So if I put 0, 0 here, since I'm decoding here, you want to take either C, if you see a bunch of zeros, something like this, then you don't know when you're decoding it, you want to group these two together or only just this one. So this is not a prefix code because C is the prefix of D. So certainly this is not the way it works. So this is not a great prefix code. So the easiest way for me is, and I think the only way in this case, write all the bit strings of length 2. So one is going to be using 0, 1. 0, 0 is 1. 0, 1 is 1. 1, 0 is 1. And 1, 1 is 1. There are only 4 bit strings of length 2. So I'll give each one 1. So this is, I'll call C, I'll call this is H, and I'll call this as D, and I'll call this as S. This is going to be a prefix code, and the corresponding code tree is given here. Left 0, right 1. I'll come here. Left 0, right 1. Left 0, right 1. Since you are using only strings of length 2, you don't need to go more than 2 levels. So if you see that 0, 0, that is going to be C. 0, 1, that is H. 1, 0, that is D. And 1, 1, that is S. This is a prefix code. And I'm giving a bit string each and everything of maximum length 2. They didn't say each and everything has to be different. All 4 of them can be of the same length. But in this case, that is the only way. Because there are 4 things and you have 4 choices. So by pigeonhole principle, one has to go to 1. So this is the prefix code. And this is the code tree. Because you are not allowed to go more than 2 digits. Am I making any sense?
Yes.
Okay.
Yes.
Okay. So for 15B, I guess, they have given you a little bit of a choice there. They were saying 1 bit string can be of length 3. So if you go into 15B, you want to give it a shot later or you want me to go over that? Add new slide, insert a new slide.
Just so that I understand, I mean, I can probably do that one on my own, but so just one of them has to be length 3 and the other 2 have to be length 2?
Let us see what they were asking. One of them has length 3 and the other 3 is shorter. They need not be of all length 2. I think one can be of length 1 also. For example, there's a pen here. If I take clubs, hearts, diamond, and spades, if I take my one as 0, 0, 0, make sure you don't take 0, 0 for the others. If you take 0, 0 or just 1, 0, then when you're decoding it, this H is going to be a prefix of C. So whatever are the others, they cannot start with 0, because if anything starts with 0, for example, if I take this as 2, 0, 1, for example, if you have bunch of numbers, 0, 1 is okay. If I take 0, 0, then it is very confusing, because when you're decoding it, you don't know whether to take 2 zeros or 3 zeros. So this is not a prefix code. Or even if you keep as 1, 0, then when you are decoding it back, people will be confused whether you need to take 1, 0 or 3 zeros together. There is certainly more than one choice. It depends on what you pick for the other ones. But you can take like that. And make sure you draw the code tree for this. For example, 0, 0, 0, if you take, the code tree is going to be left 0, again left 0, and left 0. And for example, if the one you can take as a 0, 1, for example, then this is left 0 and right 1. So this is going to be C and this is going to be H. And these can be of length 2 or 1, but you cannot take 3 again. Am I making any sense?
Yes.
Yeah.
Okay. There are certainly more than one answer here, I guess. So as long as you give me one code like this, then you're good. But that means once you take 0, 1, you cannot take like 0, 1, 0, because that is a string 3. That is the reason it's screwed up. Or also, if I take 0, 1, 0 here, then H is going to be a prefix of D. So when you're decoding it, it shouldn't lead to any confusion. That is the idea behind it. You can see that this is going to save some space compared to the previous choice. So that's what they want to emphasize here. Okay. Any other questions, folks?
I had a question about 3.6, 30A. That was about using quicksort, and I read through the example, but I have no idea how to show or represent going through the steps of that.
Oh, okay. Let us look into some of them. Let us look into the quick sort thing. The thing with the quick sort is you'll be given bunch of numbers and you want to arrange them in an order. That is what bubble sort does, and that is also quick sort does. Both do the same thing. So I will start with a very simple example and then I will go back to 30A. Okay, let us look at 30A. Let us look at some example. Say some numbers, say 2, 4, and 1, and say 3, for example. And we want to arrange them using quick sort. And please show me the intermediate steps, because we all know what the final answer is. It is going to be 1, 2, 3, 4. So really, that is ridiculous if you just give me the answer, because we all know the answer. I think every one of us knows them. So the way you need to do that is, when it comes to quick sort, if you want to arrange them, you will take one of the elements as a pivot. That means you will use them to arrange the others. You can take any one of them as pivot. Maybe I will take 2 as my pivot. Though they haven't used the word pivot there, but that is what actually it is doing. You take that and you will sort of create a wall. On the left hand side, you will keep all the numbers less than 2, and on the right hand side, you will keep all the numbers greater than 2. You don't need to write them in any order. The numbers which are less than 2 is 1. I'll keep it here. And the numbers which are greater than 2 are here. Is that making sense, guys?
Yes.
Now I will take this and apply quicksort on this again. Now I will take this and apply quicksort on this again, and 2 is going to come in the place of the wall. For example, 1, I don't need to arrange anything, so that is already done. Now I will take 4 comma 3. Now I will pick 1 as my pivot. What is my pivot? I'll take 4 as my pivot and draw a wall and write all the numbers less than 3 on the left hand side and all the numbers greater than 4 on the right hand side, because there is no number greater than 4. So there is nothing, you are done there. So 4 3 I arranged already and 1 I arranged. So 4 will fall down in the place of the wall and 1 will fall down here. And 2, once I am done with this portion and this portion, then 1 will be here, 2 will come in the place of the wall, 3 and 4 will come here. So this is sort of an iterative procedure.
Okay.
If I'm making sense to you. For example, let us look
Yes.
into the same example. Let us look into this. New slide. What is the new slide? Insert. And I should have given more slides here. Say, for example, third. Where is the pen? And the numbers are, you can pick any number as the pivot. That is the thing. So you don't need to take 5 1 7 6 3 2 4. Anybody has any preference? Which one you want to pick as your pivot? I think Nisa is the one which is asking the question. So Nisa, can you tell me which one you want to pick as your pivot?
Sure, I'll pick 4.
Okay, you'll pick 4. Now you draw a sort of a wall, and all the numbers less than 4 are going to be here, and all the numbers greater than 4 are going to be here. All the numbers less than 4, you look into 5. Okay, that is greater than 4, so I'll put it here. 1, I'll put it here. 7 greater than 4, this side. 6 greater than 4 here. 3 here. 2 here. Now I'll take this and apply quicksort again, and I'll take this and apply quicksort again. Once I'm done with this portion, 4 is going to fall in its place. So I will take 1 3 2 and now pick anything as your pivot. What is your pivot in this case? Anybody has any choice? If you put it on the chat session, I cannot see because I need to close this and go there. So can you? Okay, somebody said 2. So less than 2. So 1 less than 2. I'll put it here. 3 greater than 2. I'll put it here. Oh, that is cheeky. Now they're already ordered because I cannot apply here anymore because there are no numbers. So 2 will fall in its place. That means you're collapsing the wall and 2 is on its place. Now take 5 7 6. Now if I each one, whatever the one, you can take it and apply it, and you will get one more order. Once you will combine these two, 4 will fall down. So you will know the final answer, but you need to show me the steps.
I see.
Yes. Any other questions, folks? I'm assuming this makes sense. I just want to make sure. Any other questions?
Do you still want this turned in tonight or tomorrow?
In tomorrow, fine. I'm going to really grade this on Tuesday. So as long as you can give it to me Tuesday before 10 o'clock, I should be fine.
Okay, thank you.
Oh, anytime. Any other questions, folks? Somebody is typing. Let me go back there. Chat session. Okay. Okay. Andrea didn't have any questions. Anyone else? There were 2 people with the same last name. Are they related in any way? Oh, okay. Okay, at least you have somebody to work with then. That's great. Any other questions, folks? And at this point, I am preparing another small video on 11.1 and 11.3 and all. Hopefully, sometime tomorrow you will see bunch of videos and you'll see one more assignment. I'm going to go to chapter 11 after this, and that is going to be Euler and Hamiltonian circuits, and that should be fun. But of course, when I use the word fun, it might be only for me. I'm hoping it is for you as well. Any other questions, folks?
I think it's good for me.
Okay. Okay, that is good. Melissa has no questions. Lisa has no questions. Okay, I'm going to. It looks like people have no questions. I think so. At this point of time, again, I think I answered all of them, I guess. And I'm going to post this video for those people who missed it. I hope you don't mind. And I am assuming I have your permission to post because you are speaking in this as well. So, and feel free to submit as long as I have your work before Tuesday 10 a.m. I should be okay.
Right, great.
Okay. Thank you so much, guys. Then I'm going to stop sharing this application. Stop sharing. Okay. Thank you, guys. I'm going to stop recording now.